Ladder diagrams are specialized schematics commonly used to document control logic systems. They are called ladder diagrams because they resemble a ladder with two vertical rails, L1 and L2, and as many rungs as there are control circuits to represent. The application of a numbering system allows the ability to reference key components of a complex circuit. In this diagram, we have four rungs that comprise the entire control circuit, and we'll number them 1 through 4. When referencing wires segments associated with each rung, you start at the top left and number every wire between contacts. Thus, you would number the wire against rail L1 and the stop 1 contact as wire 1. The wire between stop 1 and the stop 2 contact as wire 2, and so on across the circuit, with each subsequent wire between contacts numbered sequentially. Any contacts in parallel will be the same wire, so there's no need to number them. Thus, rung 2 and 3 are not numbered. On the next wire against L1, rung 4, the wire between the rung and the first contact is designated wire 1, the same as in rung 1. The wire between the L2 and its nearest contact on rung 4 is also assigned the number determined on the first rung, in this case 6. The remaining wire segments between L1 and L2 are a continuation of the count from rung 1. Thus, you have wires 7, 8, and 9. Rung reference numbers are usually in parentheses adjacent to the rung in which auxiliary coil contacts and contactors are used. In this schematic, the motor coil on rung 3, M1, is referencing a normally open contact, M1. Thus, a 3 in parentheses is placed here. This reference number doesn't have a line over it because the M1 contact in this circuit is normally open. However, if the contact was normally closed, it would have a line over the rung reference number.